Hello, my name is Brian Neal. I blog at soloso.blogspot.com, soloso.blogspot.com. You can also find me on Twitter as K0EMT, Kilo Zero Echo Mike Tango. It's my amateur radio call sign. Today, what I'm going to do is give you a little tour around a solution that I've blogged about, talked a little bit about, called Batch Processor. And it's kind of an example of parallel tasking and how you can use that to do some batch processing kind of stuff. So the first aspect I want to look at is a routine called Busy, actually a console application. It's very much like the kind of like converse of the Unix sleep command. Sleep basically kind of waits for a little while, doesn't really do anything. I wanted a application that would actually exercise the CPU for some specified seconds of time. So there are some just some fluff, not really used for anything, computations in the midst of this spin method here. And so if we run it, what we're going to notice is we'll see one of the cores will spike over here as we run this. So we're waiting, it's getting busy for 10 seconds. And so we see some activity over here in the CPU area. So we know that this routine is actually doing something. I wanted to do that so that when we do the parallel tasking, you can actually see all the cores being used. If we did a sleep, you really wouldn't know that there was any activity happening. There'd be no visible Okay, so continuing on, if we look at the program class in BP console, you'll see these two basically constants defined here, serial processing and parallel processing. What this does is we're going to use the same code to execute our tasks. However, with the serial processing, we simply set it to 1, and then it will only run one process at a time. Since we have basically a quad-core machine with hyper-threading, we're going to set the parallel processing to be equal to 4. You can adjust that for your machine, your environment. We look at the main. What we're going to do is we're going to run through, we have setup tasks, parallel tasks, and teardown tasks. Typically when you're doing some sort of computation like this, you're still going to have tasks that are serialized that you cannot do in parallel. And that's what our setup tasks and teardown tasks are for. Those are for running our serial setup and teardown. For instance, we may have data preparation that all has to be done in the setup task, and then all the parallel tasks work on that data you prepared. And then the teardown tasks, we wait until all the parallel tasks are done, and then maybe we have to do something like transfer the results from those operations to another system, or say FTP them to a website, that sort of thing. We get in here, and the code for these is remarkably similar. We basically are just putting out, writing out some information to the console. We're indicating our serial processing, and the config reader. We're using a config reader of our own creation to get our list of tasks to run. So, and then of course the difference is parallel tasks. We use the parallel processing. That's pretty much all that's in there. Pretty straightforward. We'll look at our configuration file. We're set up C# Java style comments beginning of the line or even after something here. We can specify our application we want to run, or for instance we could even give it a batch job to run from in here. Maybe we have a job.bat we can run here. Parallel tasks. Now the important thing is and you'll see this to some extent in the example, that if you know you're going to have some jobs that are going to take more time than others, stack those up front, and then you put your smaller jobs in the back if you know they're going to be smaller, because then what happens is as these complete, the other jobs will fill in. If you can think about it in terms of project management and critical path, if you leave a large job at the end, that is still going to be outstanding. So your better thing is, if you know you've got long-running jobs, put them up front, and then that way at the end the little ones can fill in and work out some of those differences. The other thing to note, tear down like setup, serial fashion, but you can have more than one item here. You can do multiple items here. Processor is where it gets interesting. This is where the real work happens. We have a default, we have a constructor there. By default, it's going to, if you give it no arguments, it's going to use 2. Most of our machines out there nowadays are at least a dual core machine. So this is where you saw earlier passing in serial with 1 or parallel with 4, and our list, our job list of things to do to run through. Execute is where the interesting stuff happens, where we're setting up our number of processes to run. We go through, we set up our processes. We have to use the shell execute equals true, because if you don't do this, only exes can be run. You want to be able to potentially run batch jobs. We do some splitting to get our file name, and then we build arguments down here. We display everything in a regular command prompt style, and we're going to go and we're going to check for open processes. So while we still have a job that needs to be assigned somewhere, we're going to go through and we're going to check to see if we have a process available that we can run that in. And if we have, so that's what we're kind of doing here. We're looping through, and we're doing a modulus operator on our number of processes. So what we're doing is we're going through and we're saying we have processor 0, 1, 2, and 3, and if 2 gets done with its job first, the next job in our list will go to processor 2. So it's kind of moves around like the first available one it goes to. It's not doesn't have a processor preference or anything like that. And so we just go until all the jobs are done and all the processes are finished, and then we are complete and we're done. So let's see an example of that running. As these consoles pop up and run, you'll also note in this window we will have some writing out to it showing where we are along the way. So for instance, here we are doing our setup. So we're running setup. Okay, now we kick off. We're running our parallel tasks. See down here, 2010, 15, 8, 10. So the 10 is the one's queued up. There we go. It's jumping in. As the other ones are finishing, the other ones are dropping in. There we go, 4. And remember that 9 we talked about being at the end as being a critical path item. There we go. So if we would have put that in earlier, this whole overall might have been done earlier. And then we got our busy for our teardown at the end. So I hope you found this information useful and can put this to work in your environment.